Today we're going to learn about writing and graphing inequalities. Okay, your vocabulary that you need to know. An inequality is a mathematical sentence that compares expressions. A solution of an inequality is a value that makes the inequality true. A solution set is the set of all solutions for an inequality, and the graph of an inequality shows all the solutions of the inequality on a number line. So let's look at that a little bit further. Okay, with equations, you had an equal sign. With an inequality, you're going to use these inequality symbols. You have less than, greater than, less than or equal to, or greater than or equal to. There's also a few more key phrases to remember whenever you're writing inequalities, such as is fewer than, is more than, is at most, is no more than, is at least, and is no less than. It would be important to know these key phrases if you have a hard time visualizing what goes where. Okay, writing inequalities. Now you've seen something like this whenever we translated the words into math with equations. We're doing the same thing. We're translating words into math, but this is with inequality, using those inequality symbols. Okay, so we're going to write an inequality for each situation. There are at least 25 students in the cafeteria. So if you look here, you know there are at least 25 students. So that means, okay, there can be 25. Or there could be more. There's at least 25 in there. So that means the amount of students in the cafeteria could be greater than 25 or equal to. So you would write it as this. You choose a variable. I choose S for students. S is greater than or equal to 25. And that is your answer. Looking at the next, write an inequality for each situation. No more than 150 people can enter the game. So can 150 people enter the game? Yeah, they can. So it can be equal to 150, but no more than that. So it means it has to be 150 people or less. So the amount of people, and I chose P for my variable, is less than or equal to 150. And that's how we would write that. Okay, well what happens if we want to know if a solution is true? Meaning, can this number represent this variable? So we're going to tell in this problem whether negative 2 is a solution, is an answer of the inequality. So the first thing that we're going to do is we're going to substitute a negative 2 for y. Just like when we check equations to see if they're right, this is how you check solutions for an inequality. So all I did was plug in a negative 2, and then we're going to simplify. Solve on the left, keep change. Negative 2 plus a negative 5 gives me a negative 7. And we look, is that greater than or equal to a negative 6? No, it is not. Negative 7 is less than a negative 6. So a negative 2 is not a solution. Okay, let's look at this one. Tell whether negative 2 is a solution of this inequality. First thing we're going to do, plug in negative 2. Let's solve the left. A negative 5.5 times a negative 2 is positive 11. And is positive 11 less than 14? Yes, it is. So it is a solution for this inequality. Okay, now we're going to look at graphing inequalities. If you look at these first two examples, I use 0 just as a number to represent what we're doing because it's just easy to work with. Yeah, it could be any number, of course. So let's say that we are graphing x is greater than 0. Well, in our graph, you notice these two have an open circle above the 0. That is because x is not equal to 0 in these inequalities. So we have an open circle around it because it is not equal to it. It does not include it. Then you see that x is going to be greater than 0 here. So we're going to shade in everything to the right of that 0 because it is greater than that 0. Meaning x could be 1, 5, 100, 1,000,001. It could be anything greater than 0. So we shade in everything to the right to represent that. Same thing with x is less than 0. You do not include 0, but you're going to shade everything to the left because x is everything less than 0. Negative 1,245,000. Whatever you want it to be. Looking at the next two examples, we do have that x is equal to 0. So you notice that it is shaded in. When it is equal to, you're going to shade in that number that it could be equal to. And then continue with the shading. Here, x is greater than or equal to 0. So you are going to shade it in and then shade in everything to the right because it could be 1, 2, 1,000,000, whatever. Everything that is greater than 0. Same thing here. X is less than or equal to 0, so it's shaded in because this can be equal to 0. And then everything to the left because it's going to be everything less than or equal to 0. So let's look at this example. X is less than 34. So whenever we're going to graph this on a number line, we want to include the number that is in the problem on the number line, so 34. And then, just for this sake, I'm going to just put 3 numbers. And that if I'm having you to draw a number line, and I'm not going to give you a number line as an example, this is how I want you to do it. You can do 34, what's before 34, what's after 34. Okay, so here x is less than 34, so that means that it does not include 34, so we're going to have an open circle. And x is everything less than 34, so we shade to the left. Now I'm going to give you a helpful hint, shortcut, to remember this if you have a hard time visualizing what that inequality symbol means. If you notice that the symbol kind of makes an arrow, and this arrow is pointing to the left. That's what way we went. This only works if the variable is on this side and the number is on the right. So because this variable is on the left, this arrow is pointing to the way that it is shaded. Same thing here. The variable is on the left, so our shading is going to go to which way the arrow is pointing. So that's pointing to the right. So let's solve this. Okay, we have a negative 4. I'm going to put that in the middle. Negative 5 comes before negative 4, and negative 3 comes after. Remember, with negative numbers, you think backwards. So in this case, z can be equal to negative 4, so we're going to shade that circle in. And then it's going to be everything greater than that as well. So we shade to the right. Okay, try these on your own. See what you can do.